Hi, everybody. Hopefully, you guys are doing pretty decent and getting settled in for the long haul now in online learning. Certainly the weirdest spring I've ever had, and I'm sure most of you would agree with that. I chose the artwork that we have in the background because, of course, it is Holy Week now. And if we were in school, this would be a pretty light week because we would have retreat, we'd have Good Friday off, and so it would be a comparatively short week. And because of that, you're going to have a comparatively easy week in advanced algebra as well. In fact, sneak preview, there's no quiz this week, although there is a pretty easy assignment that you're going to have to do. We're going to start with a quick review of the stuff that you've done since we've gone online. So after learning all about rows of exponents, we learned some formulas that you could use for growth and compound interest. The basic growth formula said A equals P times 1 plus R, all to the t power. That meant the amount you're going to have in the end equaled the amount you started with, and then you took 100% and added on the amount it grew at, and you took that to the power of how long it was going to be. The other formula we had was used for compound interest, and it was just a little bit more complicated version of the same thing. It said A equals P times quantity 1 plus R over N, all to the NT power. In this formula, A was still what you had at the end, P was still what you started with, R was still the rate of growth, and T was the time. The one new thing was N, and that was how many times your money was compounded per year. So like if it was monthly, that would be 12 times a year, quarterly is 4 times a year, daily was 365. We learned those formulas, and then last week we went back and we talked about how you could take an equation and solve for an exponent in it. And to do that, we used what were called logarithms, or what was usually abbreviated logs. If I wanted to solve 3 to the x power equals 19,683, what I do is I take the log of the big number divided by the log of the number that's got x by it. So log of 19,683 divided by the log of 3. Here, this is telling me the answer is 9. So you divide logs if you want to solve for exponents. And in last week's video, I actually told you where we were going next. I told you that logarithms were going to allow us to look back at those story problems and answer the question, when? That's because if you think about it, the variable t in those formulas that we had was the exponent. And now that we know how to solve for exponents, we can solve for the time, for when. Another way to say when is how long or how much time is going to end up being required. Going along with that, I came across this really dumb thing online where it was looking at how long toilet paper will last during the quarantine. And interesting the things you come across these days. So today we're going to look at some examples that are problems where you are solving for the time, solving for when or how long. The problems we're going to look at today were all written by people that took this class last year. Some of them are in the math analysis class this year, some of them aren't taking math this year. But they're all problems that those guys wrote, and I chose some of the ones I did because some of them involve you guys that are in the class this year. And you'll find out what I mean as we go through and look at the problems. So here's our first problem. It says Joe Marin sorts 3 hogs an hour, and he increases by 10% per day. How long until Joe sorts 150 pigs per hour? So you can see, obviously, somebody just had fun writing this problem, and we even have this wonderful picture of Joe and what I think is supposed to be a pig. This is a basic growth problem, so we'll use that first formula we were looking at earlier, where the amount in the end equals the amount at the beginning, and then 1 plus r to the t power. And those problems are, of course, conveniently given to us in the problem. We want him to be able to sort 150 pigs in the end. Right now he's sorting 3. And the problem says that it increases by 10% per day, so 1 plus 0.10. So 150 equals 3, 1 plus 0.10 to the t power. In order to solve a problem like this, the first thing I've got to do is write it so that I've just got one main number on each side. You notice what I did is I took 150 divided by 3. Now what I've got is something equals something to the t. And in this case, it's 150 divided by 3 equals 1.1, which is just 1 plus 10%, to the t power. Once you've got just one number on each side, what you're going to want to do is to divide logs. And so I took the log of the answer I just got. If I wanted to, I could have just retyped log 50. But I take the log of that answer and I divide by the log of 1.1, and we get an answer that's just over 41 days. So if Joe had started this at the beginning of the time that we left school, he'd be done by the time we were back. 41 days will be our answer. The steps we did there are basically what you would do on any problem like this. You basically divide the big numbers, and then you divide the logs of those numbers. So, 150 divided by 3, log of that, divided by log of the parentheses. So here's another example, which I'm pretty positive was written by one of our seniors this year. I'm not sure if that senior was a brother of who this is about or a guy that's better known for basketball. But at any rate, it says Aiden wants to hit a golf ball 200 yards, but can only hit one 150 yards. If he improves his distance at a rate of 10% a week, how long will it take for him to hit a golf ball 200 yards? So I want you to look at that for a minute and see if you can think exactly how you would set up this problem and solve it. Again, here's your formula, so think what goes in what place as you set it up. Again, the first thing in the problem is always what you want at the end, so that's why it's 200 equals 150, what it is now, and then parentheses 1 plus the 10% it's growing by to the t power. And again, I'm working out what you would do to solve this problem. The first thing you do, and here I just went to the scientific calculator that's built into Google and did it on there. I did 200 divided by 150, which basically gives you 1 1/3, 1.3 repeating. And once you've divided 250 by 100, we take the log of that divided by the log of the parentheses. So log of the answer, which is on the Google calculator down at the bottom left corner. On most other calculators, it's second negative to get answer. The log of the answer divided by log of 1 plus 0.10. If you do that, it ends up being just over 3 weeks, which means, Aiden should be passing up the seniors by the time we get back in school. Here's a third problem. We have Cora puts $10,000 in an account. The account earns 7% interest compounded daily. When will her account have $90,000 in it? Now, whoever wrote this problem didn't bother drawing a picture of Cora, which is probably a good thing, so I decided just to put a stack of bills as a picture in there instead. This one, of course, is an interest problem, and that's why we're going to use the more complicated formula, A equals P, quantity 1 plus R over N, all raised to the NT power. So again, take a minute, look at that, and see if you can think what would go where. Again, it's always what you have at the end that comes first, followed by what you started with. So 90,000 equals 10,000. 1 plus, and it's 7% interest, which is why I put 0.07. It's compounded daily, which is why I put over 365. And again, that 365 comes up not just in the bottom of the fraction, but also in the exponent. So 90,000 equals 10,000 times 1 plus 0.07 over 365 to the 365t power. And here's what I would do if I was working this out on a calculator. Again, I start off by dividing the big numbers, 90,000 divided by 10,000, which honestly I could do in my head, and I know that's 9. Now I do 3 different things. I took the log of that answer, divided by the log of the parentheses, 1 plus 0.07 over 365. And then at the end, what I did is I divided by the 365 that's in the exponent. I divide the 2 logs, and then I divide by the 365 that's next to t to cancel it out. I end up getting about 31.4 years, which sounds like a long time, but if you think about it, she's going to have 9 times as much money as she started with, and 31 years is not too bad for that to happen. So the basic process when you have these interest problems is you do divide those numbers at the start, 90,000 divided by 10,000. Then you divide logs, the log of what you just got divided by the log of the parentheses. And finally, you divide by the number in the exponent. I did those last 2 steps all on one line on the calculator. Sometimes it's easier for people to hit equal or enter after you divide the logs, and then just tag on at the end, divided by 365. And that's fine. That'll work out and give you the same answer. I told you these were written by people that were in this class last year, and this was one of the people that was in the class last year. It says if Eric puts 69 bucks in the bank, compounded quarterly at 10% interest, how long will it be before he has $700? Now I wrote the key numbers down at the bottom because it's a little bit hard to read that handwriting at the top. But again, I want you to look through that and see if you can figure out how you would set everything up and how you'd solve the problem. Again, your formula is written at the bottom there. You have the amount at the end, the amount at the beginning, the rate of interest, and the number of times compounded per year. And of course, the t power comes up in the exponent. So here, that's going to be 700 equals 69 times 1 plus 0.10 over 4, all raised to the 4t power. Solving it is the same basic stuff as before. I divided those numbers at the beginning, 700 divided by 69. I take the log of that, divided by the log of 1 plus 0.10 over 4, what's in the parentheses. And finally, I divide by the 4 that's in the exponent. And here we get about 23.5 years. Here's another one that goes back to just the basic growth formula. Carolyn has 20 hair scrunchies. Her collection grows at a rate of 2% per month. She wants to have 40 hair scrunchies. How long will it be until she has 40 of them? So I'm going to shut up for a minute and see if you can work everything out with this one. So the formula on this one, we've got 40, the number she wants in the end, equals 20, which she starts with, times 1 plus 0.02 to the t power. You're going to divide 40 divided by 20, of course that's 2. You take the log of that 2, divided by the log of the parentheses, 1.02, and what you end up getting is basically 35 months. When you have those general growth problems, if you were labeling your answer, it's always whatever the unit was in the problem, so here it is months. And here's another interest problem. I'm pretty sure there's no one in either class that's named Sally, but we do have Sally puts in $6,000 in her account. It earns 4% interest compounded quarterly. When will the account reach 30,000 bucks? So again, let's see if you can figure out this answer. And here we're going to have 30,000 equals 6,000, and then 1 plus 0.04 over 4 to the 4t power. There's some people like to simplify these things ahead of time, like 1 plus 0.04 over 4 is just 1.01. You could certainly do that if you wanted to, and there's no problem with it. So this time I did a couple of things in my head when I worked this out. I first of all took 30,000 divided by 6,000, which is just 5. And like I was saying before, I also knew that 1 plus 0.04 over 4 is just going to be 1 plus 0.01 or 1.01. So what I did then is I divided the log of 5 divided by the log of 1.01, and like always, we divide by the 4 that's in the exponent. And the answer we get is a little over 40 years. People will sometimes ask, how do you know how to round your answer on a problem like this? You always could just write down everything, but it's usually okay to round to 1 or 2 decimal places, so I'd probably put 40.4 years. And when you do have compound interest problems, the answer is always in years. And we're going to end today with a problem that's about the brother of somebody in this class. And it says here that John won the lottery and now has $5 million. He spends this at a rate of 5% daily. When will he have $25,000? Now, sometimes whenever people see money in the problem, they think it's going to be one of the compound interest problems, and they'll go for that more complicated formula. This one actually is not a compound interest problem. You can tell that for a couple of reasons. One of them is that it doesn't have the word compounded in it anywhere. The other thing is that the amount's going down instead of up. And because it's going down, what we're going to do is use that basic growth formula, but with a minus in it because it's going down. So we got 25,000 equals 5 million, 1 minus 0.05 to the t power. I'm going to give you guys just a minute to see if you can work out the answer there. Just like always, we start by dividing those numbers at the beginning, 25,000 divided by 5 million. And then I've got to divide the log of that divided by the log of the parentheses. There's nothing else in the exponent, so I don't need to divide by anything there. And what I end up getting on this is a little bit over 103 days. So that would be, about 4 months that you're going to end up with, but 103.3 days. I told you at the beginning that there's no quiz this week. There'll be a little worksheet posted on the website that gives you some more opportunity to practice this, but it won't be until a week from now, after Easter, when you actually get back and have a quiz over that. You do, however, have a quick assignment, and it counts the same as a quiz would. What you need to do is you need to write 2 story problems of your own. If you get totally stuck, you can go back, look at some of the examples, and just sort of change around the name and numbers, and that's the easy way to do it. But what you want to do is to write two problems, one of which is a basic growth problem. It could be like the hair scrunchies for Carolyn. Another one is a compound interest problem, like Cora's bank account. And you come up with two different story problems. You can get extra credit for doing illustrations, which you can see from the examples we did don't need to be good art, but you can do some illustrations with them. And if you have things that are particularly creative, you can get some extra credit for that as well. So one basic growth problem and one compound interest problem. And what you need to do is to either write those in an email, or you can take a picture of it on your phone and send it to me. And I've got either the email or a phone number you can send those to and get those to me. And like I say, that is going to count the same as the quizzes do in terms of points for you. So you do want to make sure that you get those in this week. So with that, I'll wish you a good Holy Week and a happy Easter. I could say I hope you're enjoying your month and a half long Easter break, but I had somebody that I saw at the grocery store the other day that said, "Oh, you must be enjoying all this time off." And I felt like slapping him because it's been a lot of work and a lot of boredom combined. And I'm sure that's been true for you guys as well. So let's make the best of it and get through it, and hopefully we'll actually see each other before too long. Happy Easter.